Continuing on with problems for area of a sector. A sector with radius x and central angle 50 degrees has area of 8 pi. Just to remind you, what does the formula look like? It's a equals theta pi r squared over 360. And in this case, do you see that they're giving us the radius as x? So we don't have everything on the right side, but they do give us the area of pi. So we're going to put 8 pi equals theta, which we know is 50 degrees, times pi times r squared, which is x squared, divided by 360. And then we can solve this with algebra, or we could use the solver in the calculator. So let me demonstrate how to do that. So I'm going to math and go to the bottom of this column, and there's solver. And then for the left side, I'm going to put in E1, and the right side I'm going to put E2. So the left side is 8 pi, and the right side is 50. Let's do the vertical fraction first. So math, number, go to the bottom. And we're going to put 50 and pi on top. X squared. And on the bottom, I'm going to put 360. And then I'm going to say OK. And then I'm going to press alpha solve for x. And the answer is 7.59. Okay. So if I wanted to solve this using algebra, I would multiply both sides by 360. I would divide both sides by 50. I would divide both sides by pi. And then I would take the square root of everything. Okay? All right. Let's look at number 4. Find the area of the segment enclosed by the chord BC and the subtended arc with radius 4 and the central angle 55. So this is pretty straightforward. We are just going to use the right side of the formula. We don't know what A is, so we're going to put 55 degrees. We're going to put pi r squared, which is 4 squared, and we divide by 360. And we don't need to use this. We could just use vertical fraction, which is over here under number. Go to the end, enter. And we're going to put 55 pi 16 on top. 55 pi 4 squared, which is 16 on top. And on the bottom, we're going to put 360. And that's our area. Oh, I just noticed something. It's not asking us just for the pizza shape here. They know just that darkened shape right there. They want to know the pizza crust, right? So the total area of the pizza is 7.68. How do we find just the pizza crust? Well, we're going to have to subtract out this part that's not the crust. Okay, how do we find the area of that? Now we need to go back in our memory and we need to remember how to find the area of a triangle, a non-right triangle, in which we know 2 of the sides and we know the angle in between the 2. And if you remember, the area for this triangle is 1/2 BC sine A, or 1/2 AB sine C. So basically what we need to do is we need to put the angle in here, and then the B and the C would be the sides that are adjacent to the angle. So it would be 1/2 times 4 times 4 times the sine of 55. And this is a problem where we do need to put the mode into degrees, because this is a problem that we're using sine and cosine, right? So we're going to put 0.5 times 16 times the sine of 55. And that gives us 6.55. So that would be the red part of the pizza. And so what we need to do to find the crust is we need to do 7.68 minus 6.55, which would be E2. Just going to grab the numbers here by highlighting them and then pressing enter. So we do minus, and then I go over to 6.55 and highlight it and press enter also. And the difference, which would be the crust, is 1.13. Okay? Okay. Ugh. So that is a favorite problem of the IB, to do shapes like this, because do you see how they tested you on area of a sector, and they also tested you on area of a non-right triangle, all in one problem. Okay, last problem on this page. It is, let me move this up a little bit. A landscaper builds a rectangular hexagonal patio in a circular garden. The area not covered by the patio will be covered in grass. The radius of the garden is 1.5. The area covered by the grass in the garden is basically the pizza crust, right? So the pizza crusts are the area that are not covered with the patio. Okay, so this is very similar to the problem that we just did. The only difference is there's 6 pizza slices instead of just 1, right? So what if we just did the calculation of the pizza crust for one of the slices, and then we just multiplied it times 6? Okay, so let's do that. I'm going to draw one of these pizza slices. Okay, and then the only tricky thing about this is they don't tell us this angle here, but we can figure it out because there's, if this was a pizza, we cut it into 6 equal slices. So basically, when you have a hexagon like this, the angle here is 60 degrees, right? So if I want to find the pizza crust, I'm going to use the sector formula, which is theta divided by 360 times pi r squared to find the entire pizza, and then I'm going to subtract out the triangle. So this is 60 degrees divided by 360 times pi, and then the r value is 1.5, right? So I can do that on my calculator here. 60 divided by 360 is 1/6, right? So I'll have 1/6 times pi. Oops. Where's the parentheses? Pi 1.5 squared. 1.5 squared. And that gives me 1.18 for the whole pizza. And then the triangle part of the pizza I can find with the area of a non-right triangle formula, which is 1/2 BC sine A. So that would be 1/2 times 1.5 times 1.5 times the sine of 60 degrees. That would be 0.5 times 1.5 squared times sine of 60. And I already put it in degree mode, so I don't need to do anything there. So the answer for that was 0.974. And then I'm going to subtract the 2 to find the crust. And that's going to be 1 crust, and I need to multiply that times 6 in the end, right? So my crust is 1.18. And I'm going to subtract, or that's not my crust, that's the whole pizza and the whole pizza piece. And then this is subtracting the non-crust part, and the crust part is 0.204. And then I multiply that times 6 to get the entire area covered by grass, which would be 1.22. That's it. That's it for page 3.